Hi, I'm Subhashni, and today I'm here to talk to you about the third part of the question and answer series for the AI for Business course, where we are going to look at the unsupervised reinforced learning, right? So that's unsupervised and reinforced learning. The first question which will come to your mind, of course, is that what exactly is unsupervised learning? And let's look at what is unsupervised learning. We already understand that supervised learning is what really makes a lot of sense for labeled data. Unsupervised learning is a type of machine learning where there are no correct answers which are given to the machine. So there is no labeling that this output is good or bad or right or wrong, etc. This is the most important thing that you must remember, that unlike supervised learning, there are no labels, no right or wrong, and no teacher with an answer key. The machine is asked to explore the data on its own. If we look at a real life analogy, imagine that you are given a large pile of exam papers, no subject names, no grades, no student details. You are asked that group these papers into a meaningful way. So, what would you do? You might group by handwriting, group by difficulty, or group by similarity of the answers. This is exactly what unsupervised learning does. How does unsupervised learning work in machines? Let's take a look at that. The first thing is the model receives the raw data and it looks for similarities, differences, patterns, and structures. It creates groups or representations. Humans then interpret those results. That is, the machine does not know what is correct or what is good. The machine only knows what is similar. Also, it knows what is dissimilar. So, these two are not similar. Why unsupervised learning is important? In business, we often don't know what to look for. We want insights, not predictions. We want to understand behavior, not judge it. So, unsupervised learning answers questions like, what type of customers do we have? Are there hidden patterns in the behavior of our customers? Is there something unusual happening? So, unsupervised learning works very well when we want to do exploration, discovery, and in the early stages of analytics projects. Also, you know that now a lot of unstructured data, video, audio data is available, text data is available, and therefore it works very well with data sets of this kind. The next question you might have is, what problems does unsupervised learning solve? So the problems that unsupervised learning solves is generally of three kinds. The first kind is clustering. Clustering means grouping similar data points together. The machine answers which data points look alike. It therefore also answers the reverse, which is that which data points do not look alike. They look very different. Now, for a business example, this would be something like customer segmentations. So customers can be grouped based on buying behavior, frequency, and spending. No predefined labels like premium or budgets are available, and the machine discovers these groups organically. The managers then look at the characters of these groups and they can name the segments like DINK, double income, no kids, right? This is actually just a marketing name for a certain type of behavior. The second could be dimensionality reduction. So, all the time, unsupervised learning may be not used as a final outcome. It can be used as a part of a project within even supervised learning. Okay, so dimensionality reduction is modern databases often have hundreds of variables and there are complex relationships between the x variables and the x and y variable. There's also a lot of redundancy. A lot of the x variables are very similar. Like if I have age and age group, both of these would be pretty similar, right? Age group is actually defined by age. So dimensionality reduction simplifies the data, reduces the noise and retains the important information. For example, it will retain only a few of the X variables, like in surveys, psychometric assessments, and customer feedback forms. Instead of the 200 questions that we have asked, The model may identify five core dimensions like motivation, engagement, and risk aversion, and then only group on the basis of those. The third type of outcome is anomaly detection. Okay, anomaly is mainly outliers. These are rare events, unusual behaviors, and the, of course, as I mentioned, outliers. The business examples is credit card fraud or network intrusions or equipment failure. So, what do we question? We ask what looks very different from what is normal. Why these problems matter? Because business risk and opportunities do not come with labels. They are often hidden in raw data and appear only as deviations. Unsupervised learning helps managers to ask better questions, understand the landscape, and prepare for predictive modeling later on. So if we were to look at it, supervised learning predicts outcomes because there's a clear labeling. Unsupervised learning reveals outcomes saying that these are similar and dissimilar. Not unsimilar, dissimilar. Okay. So now we come to the next question, which is how is unsupervised learning used in business? If we were to look at it, unsupervised learning is most powerful when business want to understand and not decide immediately. So, if we want to have some segmentation of customers based on behavior, we want to identify high value, low value, and dormant groups of customers and personalize marketing strategies. For example, a retailer discovers a frequency but low spend segment. So, these guys buy frequently but they spend less amounts. Okay, that was invisible earlier. So, what you want to do is you might want to provide certain type of offers for this segment. Like I have noticed this time Swiggy has come up with a zero delivery fee offer. Okay, risk and fraud exploration, where you want to detect unusual transactions, identify new fraud patterns, something which is unusual and not occurred before, and flag anomalies for human review. Unsupervised learning acts like an early warning system. And when you look at data preparation for supervised models, often the data is messy and the variables are redundant. So, unsupervised learning can actually help reduce dimensionality, find the few X's which really matter, improve data quality, and make supervised models more effective. So, what are we saying? Often in a creation of a model, you can have a couple of learning algorithms which are working at different stages. Visualization and insight generation. Managers often struggle with large tables and complex dashboards. Unsupervised learning helps visualize these structures, tell stories with the data, and support strategic discussions. Strengths are no label data is needed and it is useful when problems are unclear. It encourages exploration, supports innovation. But there are some limitations. Limitations are interpretation is subjective, results is not answers, and it often requires domain expertise to actually understand exactly how to use the outcome. This brings us to the next type of learning, which is reinforced learning. What exactly is reinforced learning? It is fundamentally different from both supervised and unsupervised learning because it is learning through experience, which is actually how humans learn. So, if we want to think of how we learned how to ride a bicycle, there's no instruction manual. You try, you fail, you adjust, and you improve. Nobody is able to give you correct answers, labels, or instructions for every situation. You learn through trial and error, and this is what reinforcement learning does. There are five core elements of reinforcement learning. There's an agent, the learner or decision maker. There's an environment where the agent operates. So some learning will only work in that context, right? Actions, whether what the agent can do, and some reward. There's feedback, positive or negative. Policy, strategy to choose actions. All of these are part of any reinforcement learning. Okay. The idea is to maximize long term rewards and not immediate gains. Business example include dynamic pricing systems, recommendation engines, inventory optimization, traffic routing, and robotics. So, a pricing system will test small price changes and observe customer response over periods of time. Then they know that the customers often buy this type of a product in this range of pricing, right? So, why reinforcement learning is powerful? It handles sequential decisions, adapts to changing environments, and optimizes long-term outcomes. Okay. Now we have to understand that reinforcement learning is often trained on simulations and human oversight is essential. So if we were to summarize what we've understood in this part 3, it is that supervised learning learns from the past, unsupervised learning explores the present, and reinforcement learning shapes the future. I do hope you have liked and subscribed to the channel so that we can share with you part 4, where we will look at crisp DM and leadership questions. Thank you.